Saturn's rings are disappearing. What does that mean for us? Part 1. The beauty and mystery of Saturn's rings. Saturn, the sixth planet from the Sun, has long captivated humanity with its magnificent system of rings. These ethereal bands of icy particles and dust create a celestial spectacle, visible even through modest telescopes. For centuries, their existence has fueled both scientific inquiry and artistic wonder, inspiring poets, astronomers, and dreamers alike. The sheer scale and intricate structure of the rings evoke a sense of profound beauty, making Saturn a crown jewel of our solar system. Their origin and longevity, however, have remained subjects of intense scientific debate, adding to their enigmatic allure. The rings represent a dynamic cosmic laboratory, offering clues not only about Saturn itself, but also about the processes that shape planetary systems across the galaxy. The rings of Saturn are not solid structures, but rather a vast collection of billions of individual particles, each orbiting the planet like tiny moonlets. These particles range in size from micrometers to several meters, reflecting sunlight with dazzling brilliance. Their collective reflection is what gives the rings their characteristic luminosity and distinct appearance. The intricate patterns observed within the rings, including gaps and divisions, are a testament to the complex gravitational interactions at play. These features suggest a dynamic environment where forces constantly sculpt and reshape the ring system, hinting at an ongoing cosmic ballet that continues to unfold before our eyes. The very presence of such an elaborate ring system around a gas giant like Saturn raises fundamental questions about planetary evolution. Why does Saturn possess such prominent rings, while other gas giants like Jupiter, Uranus, and Neptune have much fainter or less extensive systems? This disparity suggests that the conditions necessary for ring formation and maintenance are specific and perhaps transient. Studying Saturn's rings provides a unique opportunity to understand the broader mechanisms that govern the assembly and decay of circumplanetary disks. Their existence serves as a powerful reminder of the diverse and often spectacular phenomena that populate our universe, challenging us to look beyond the familiar and explore the extraordinary. The ring's exquisite beauty has also imbued Saturn with cultural and symbolic significance throughout history. Ancient civilizations observed Saturn's slow, deliberate movement across the night sky, associating it with time, agriculture, and wisdom. This rich tapestry of human observation and interpretation has woven Saturn into our collective consciousness, making it more than just a distant celestial body. It is a source of inspiration, a subject of myths, and a beacon for scientific exploration. The rings, in particular, serve as a visual emblem of this enduring fascination, a celestial signature that sets Saturn apart as a truly unique and awe-inspiring world. Part 2. Discoveries from Cassini spacecraft. The Cassini spacecraft, a joint mission by NASA, ESA, and ASI, revolutionized our understanding of Saturn and its intricate ring system. Launched in 1997, Cassini arrived at Saturn in 2004 and spent over 13 years meticulously studying the planet, its rings, and its diverse moons. Its unprecedented close-up observations provided a wealth of data, revealing the rings to be far more complex and dynamic than previously imagined. Cassini's instruments allowed scientists to analyze the composition of the ring particles, map their gravitational interactions, and observe the subtle yet profound changes occurring within the system. This wealth of information transformed our conceptual models of ring dynamics and evolution. One of Cassini's most significant discoveries was the intricate substructure within the main rings. The spacecraft unveiled countless tiny ringlets and density waves, ripples caused by gravitational nudges from Saturn's moons. These features, often invisible from Earth, provided direct evidence of the subtle gravitational sculpting at work. Cassini also confirmed the presence of propellers, small moonlets embedded within the rings that create distinctive propeller-shaped gaps in the surrounding material. These discoveries demonstrated that the rings are not a static entity, but a constantly evolving system, shaped by a complex interplay of gravitational forces and particle collisions. Cassini's instruments also provided detailed insights into the composition of the ring particles. The data confirmed that the rings are predominantly composed of water ice, with only a small fraction of rocky material. This high purity of ice has profound implications for theories of ring formation, suggesting a relatively recent origin. Furthermore, Cassini detected traces of various organic molecules, particularly within the F-ring, hinting at chemical processes occurring even in this seemingly barren environment. These compositional analyses have helped scientists piece together the history of the rings, offering clues about their birth and subsequent evolution over millions of years. Beyond the rings, Cassini also provided invaluable data on Saturn's atmosphere and magnetosphere, and made astounding discoveries about several of its moons, particularly Titan and Enceladus. However, its close-up views of the rings, including spectacular images and spectral data, truly redefined our understanding of these iconic structures. The mission concluded in 2017 with a dramatic plunge into Saturn's atmosphere, a maneuver designed to protect potentially habitable moons from contamination. Even after its fiery end, the vast trove of data collected by Cassini continues to be analyzed by scientists worldwide, revealing new insights into the wonders of the Saturnian system. Part 3: Evidence of Vanishing Rings. Recent observations and analyses of data from the Cassini mission have presented a surprising and somewhat sobering revelation. Saturn's iconic rings appear to be slowly but steadily disappearing. This isn't a sudden cataclysm, but a gradual process of decay, driven by a phenomenon dubbed ring rain. The electrically charged icy particles that comprise the rings are being drawn in by Saturn's powerful magnetic field, pulled towards the planet's atmosphere by gravity and electrostatic forces. This continuous inward drift of material means that the rings, while vast, are not eternal structures, but are slowly being depleted of their constituent particles. Scientists have observed evidence of this ring rain through various mechanisms. Cassini's instruments detected water-bearing ions flowing along magnetic field lines into Saturn's upper atmosphere. These ions originate from the rings, having been charged by ultraviolet light from the sun or by plasma from micrometeoroid impacts. Once charged, they become susceptible to the planet's magnetic field, which acts as a conduit, guiding them downwards towards the equatorial regions. This continuous influx of icy particles represents a significant loss of material from the ring system, contributing to its slow but inevitable demise over geological timescales. The rate of this ring rain has been estimated, and the figures suggest a relatively rapid disappearance on a cosmic scale. Researchers calculate that enough ring material is falling onto Saturn to fill an Olympic-sized swimming pool every half an hour. While this might seem like a slow drip compared to the rings' immense size extrapolated over hundreds of millions of years, it signifies a substantial loss. This evidence challenges the notion of the rings as permanent fixtures of the solar system, instead portraying them as ephemeral marvels, caught in a dynamic process of creation and destruction. The implications of this vanishing act are profound. If the rings are indeed disappearing, it suggests that they have a finite lifespan, potentially much shorter than the age of Saturn itself. This observation forces scientists to reconsider previous assumptions about the rings' longevity and prompts new questions about their origin. The realization that one of the solar system's most magnificent features is slowly fading away adds a new layer of urgency and fascination to our studies, emphasizing the dynamic and ever-changing nature of the cosmos. The majestic rings are a fleeting spectacle, and we are fortunate to witness them in their current glory. Part 4. How old are the rings really? For many years, it was widely believed that Saturn's rings were as old as the planet itself, formed alongside Saturn from the primordial dust and gas of the early solar system. This ancient rings hypothesis suggested that the rings had persisted for billions of years, a stable and enduring feature of the gas giant. However, evidence gathered from the Cassini mission, particularly regarding the rings' composition and the observed ring rain, has cast a significant doubt on this long-held assumption. Scientists are now increasingly leaning towards a much younger age for Saturn's rings, a timeline that profoundly alters our understanding of their history. One of the strongest pieces of evidence for a youthful ring system comes from their pristine composition. The rings are remarkably bright and overwhelmingly composed of pure water ice, with very little rocky or dusty material. If the rings had been present for billions of years, they would have accumulated a significant amount of dark, dusty debris from meteoroid impacts, causing them to appear much darker and more contaminated. The observed purity suggests that the rings have not been exposed to the harsh environment of space for an extended period, implying a much more recent formation event. The estimated rate of ring rain further supports a younger age. If the current rate of material loss has been consistent throughout the rings' history, then extrapolating backwards suggests that the rings could not have survived for billions of years. The continuous depletion of icy particles implies a finite lifespan, and if they were ancient, they would have completely vanished by now. This calculated decay rate provides a powerful constraint on the maximum possible age of the ring system, pushing scientists to consider formation scenarios that occurred much more recently in the solar system's history. Current estimates suggest that Saturn's rings may be no more than 10 to 100 million years old, a mere blink of an eye in cosmic terms. This makes them significantly younger than the dinosaurs, and a relatively recent addition to the Saturnian system. This revised age dating fundamentally changes our perspective on these iconic structures, transforming them from primordial relics to relatively new, albeit grand, phenomena. The quest to precisely determine their age remains an active area of research, with ongoing analysis of Cassini data expected to refine these estimates further. Part 5. Theories of ring formation. The realization that Saturn's rings are relatively young, rather than primordial, has revitalized theories about their formation. The leading hypothesis now centers on a catastrophic event that occurred much later in Saturn's history. One prominent idea suggests that the rings originated from the breakup of a small icy moon, or perhaps a comet, that ventured too close to Saturn. As this celestial body approached the planet, it would have been subjected to immense tidal forces, eventually tearing it apart into countless smaller fragments. These fragments, unable to escape Saturn's gravitational pull, would then have spread out to form the spectacular ring system we see today. Another compelling theory proposes that two icy moons collided within Saturn's system. Such a collision, if violent enough, could have shattered both moons into a vast cloud of debris. The fragments from this impact would then have been dispersed around Saturn, eventually settling into the thin, disc-like structure of the rings. The high purity of water ice in the rings lends credence to this idea, as icy moons are common in the outer solar system. The precise conditions of such an impact, including the size and composition of the colliding bodies, would dictate the characteristics of the resulting ring system. Some models also consider a scenario involving a larger, differentiated icy moon that was tidally disrupted. If a moon with an icy crust and a rocky core was torn apart, the lighter icy material might preferentially form the bright, pure rings, while the denser rocky core material could have either fallen into Saturn or coalesced into new, smaller moons. This differentiation process could explain the rings' low rocky content. Understanding the exact sequence of events requires detailed simulations and further analysis of the physical and chemical properties of the ring particles. Regardless of the specific mechanism, all contemporary theories of ring formation now emphasize a relatively recent cataclysmic origin. This shift from primordial formation highlights the dynamic and often violent nature of planetary systems. The rings are not merely passive structures, but the remnants of a dramatic, cosmic event, a testament to the powerful gravitational and collisional forces that shape worlds. Unraveling the precise circumstances of their birth remains a key objective, offering insights into the broader processes of moon and planet formation in the outer solar system. Part 6. The Physics of Icy Particles and Dust. The intricate beauty of Saturn's rings is a direct consequence of the complex physics governing the behavior of billions of icy particles and dust grains. These individual components, ranging from microscopic dust specks to house-sized boulders, do not simply orbit Saturn independently. Instead, they interact constantly through gravitational forces, electrostatic charges, and direct collisions, creating the mesmerizing patterns and structures observed within the rings. Understanding these fundamental physical interactions is crucial to comprehending the rings' stability, evolution, and eventual disappearance. Each ring particle is in orbit around Saturn, but their paths are constantly perturbed by the gravitational pull of neighboring particles and, more significantly, by Saturn's numerous moons. These gravitational nudges create density waves, ripples that propagate through the ring plane, and also sculpt the distinct gaps and divisions that characterize the ring system. For instance, the Cassini division, a prominent gap between the A and B rings, is largely maintained by the gravitational resonance with Saturn's moon Mimas, which clears out particles at a specific orbital distance. Collisions between ring particles are also a pervasive and essential physical process. While individual particles are small, their sheer number ensures frequent encounters. These collisions can be either gentle, leading to particles bouncing off each other, or more energetic, causing fragmentation or accretion. Gentle collisions contribute to the ring's remarkably thin structure, as particles tend to settle into a single plane. More energetic impacts can generate fine dust, replenish electrostatic charges, and even influence the overall distribution of material within the rings, contributing to their dynamic evolution. Electrostatic forces also play a surprising role, particularly for the smallest dust particles. When exposed to sunlight and plasma from Saturn's magnetosphere, ring particles can acquire an electrical charge. These charged particles can then be levitated above the main ring plane, or influenced by Saturn's magnetic field, contributing to phenomena like the spokes observed in the B ring, which are transient radial features. The interplay of gravity, collisions, and electromagnetism orchestrates the elaborate cosmic dance of Saturn's rings, a dynamic system where microscopic interactions yield macroscopic wonders. Part 7. Moons shaping the rings. Saturn's extensive family of moons plays an indispensable role in sculpting and maintaining the intricate structure of its rings. These celestial shepherds, ranging from tiny moonlets embedded within the rings to larger, more distant satellites, exert gravitational influences that create the stunning patterns and divisions observed. Without the ceaseless gravitational tugs of these moons, the rings would likely be a more uniform and less visually captivating disk. Their presence transforms the ring system into a dynamic laboratory of orbital mechanics, where each moon's motion leaves its unique signature on the surrounding icy particles. Some moons act as, quote, shepherd moons, orbiting just inside or outside the main ring edges. Their gravitational pull prevents ring particles from straying too far, effectively confining the rings and maintaining their sharp boundaries. For example, the tiny moons Pandora and Prometheus shepherd the F ring, keeping its narrow, braided structure intact. As ring particles approach these moons, they are either pushed away or pulled inwards, depending on their relative position, preventing them from dispersing into space and maintaining the ring's distinct form. Larger, more distant moons are responsible for the prominent gaps and divisions within the rings. The moon Mimas, for instance, is famously credited with maintaining the Cassini division, the largest gap in Saturn's rings. Ring particles within this division are in a 2-to-1 orbital resonance with Mimas, meaning they complete 2 orbits for every 1 orbit of Mimas. This repeated gravitational tug at the same point in their orbit eventually clears out the particles, creating the distinct gap. Similar resonant interactions with other moons are responsible for many of the smaller gaps and wave patterns throughout the ring system. Beyond creating gaps and boundaries, moons can also cause waves to propagate through the ring material. These density waves and bending waves are analogous to ripples on a pond, created as ring particles are periodically disturbed by a passing moon. By studying the characteristics of these waves, scientists can infer properties of the ring particles themselves, such as their density and mass. The complex and diverse family of Saturnian moons acts as a constant architect, perpetually shaping and reshaping the magnificent ring system through a gravitational ballet that spans millions of kilometers. Part 8. Saturn's Storms and Atmosphere Secrets. Beyond its magnificent rings, Saturn is also a world of dynamic atmospheric phenomena, characterized by colossal storms and intriguing weather patterns that conceal secrets about the planet's internal workings. Like Jupiter, Saturn is a gas giant, primarily composed of hydrogen and helium, but its atmosphere presents its own unique mysteries and spectacular events. Studying these atmospheric dynamics provides crucial insights not only into Saturn itself, but also into the general principles governing the atmospheres of other gas giants throughout the cosmos. One of the most striking features of Saturn's atmosphere is the hexagonal jet stream at its north pole. This persistent, six-sided storm, spanning about 30,000 kilometers, has captivated scientists since its discovery by the Voyager spacecraft and was extensively studied by Cassini. The hexagon is a stable wave pattern in a fast-moving jet stream, a unique phenomenon not observed on any other planet in our solar system. Its long-term stability and precise geometric shape pose significant challenges to atmospheric models, hinting at complex internal dynamics deep within the planet. Saturn also experiences colossal storms, sometimes referred to as, quote, great white spots, which can be large enough to engulf Earth. These powerful convective storms erupt periodically, often appearing as bright, sprawling clouds that encircle the entire planet. They are driven by massive upwellings of warm, moist gas from deeper within Saturn's atmosphere, bringing material from lower layers to the surface. These storms provide a rare glimpse into the planet's internal heat engine and atmospheric circulation, revealing the immense energy inherent in gas giant weather systems. Cassini's observations also provided detailed data on Saturn's atmospheric composition, temperature profiles, and wind speeds. The spacecraft detected lightning discharges within Saturnian storms, confirming the presence of powerful thunderstorms. By tracking cloud movements, scientists mapped incredibly fast winds, particularly near the equator, reaching speeds of up to 1,800 kilometers per hour. These atmospheric studies, while distinct from ring research, collectively contribute to a holistic understanding of Saturn as a complex and ever-changing planetary system, from its majestic outer rings to its turbulent inner depths. Part 9. Symbolism of Saturn in History and Astrology. Throughout human history, Saturn has held a profound and often contradictory symbolism, evolving from a harvest deity to a bringer of limitation and wisdom. In ancient Roman mythology, Saturnus was the god of agriculture, wealth, and liberation, and was revered during the winter solstice festival of Saturnalia. This benevolent aspect reflected the planet's slow, steady movement across the sky, reminiscent of the rhythmic cycles of planting and harvesting. Yet, even in antiquity, Saturn also carried connotations of old age, melancholy, and fate, a duality that continues to resonate in its astrological interpretations. In various ancient cultures, Saturn was often associated with time itself, largely due to its stately and deliberate orbit, which takes nearly 29.5 Earth years to complete a single circuit around the Sun. This long period made it a celestial clock, marking generational shifts and the passage of eras. Its distant position and faint light also contributed to an aura of detachment and introspection. These associations laid the groundwork for Saturn's later role as a symbol of cosmic order, structure, and the boundaries that define existence. In modern Western astrology, Saturn is frequently referred to as the taskmaster or the great teacher. It symbolizes discipline, responsibility, hard work, and the lessons learned through challenges and limitations. Astrologers believe that Saturn's influence highlights areas where individuals need to develop maturity, perseverance, and structure. While often associated with difficulties and restrictions, Saturn's ultimate purpose in this framework is seen as growth and self-mastery, shaping character through experience and demanding accountability. The dual nature of Saturn, both a constructive force of order and a challenging agent of restriction, reflects humanity's complex relationship with time, responsibility, and the natural cycles of life. From ancient agricultural rituals to contemporary astrological charts, Saturn's enduring symbolism underscores its powerful psychological and cultural impact. The magnificent rings, a recent addition in cosmic time, serve as a fitting visual metaphor for this complex symbolism. Beautiful and expansive, yet also a system defined by boundaries, structure, and a gradual, inevitable decay, echoing themes of existence and impermanence. Part 10. What Saturn's fate tells us about planetary systems. The slow but inexorable disappearance of Saturn's rings, a process predicted to unfold over millions of years, offers profound insights into the dynamic nature of planetary systems throughout the universe. Far from being static or eternal, celestial structures are constantly evolving, shaped by gravitational forces, collisions, and the relentless march of time. Saturn's rings serve as a powerful, albeit temporary, demonstration of these cosmic processes, providing a unique window into the life cycle of planetary features and potentially informing our understanding of exoplanetary systems. The revelation that Saturn's rings are relatively young and have a finite lifespan suggests that such magnificent ring systems might be common but transient phenomena around gas giants across the galaxy. It implies that at different points in their history, Other gas giants in our solar system, or exoplanets orbiting distant stars, might have possessed equally spectacular ring displays that have since faded away. We might simply be witnessing Saturn during a particularly glorious phase of its existence, a fleeting moment in cosmic history, where its rings are at their most prominent. Moreover, the mechanisms driving the rings' demise, primarily ring rain caused by magnetic and gravitational forces, highlight the intricate interplay between a planet and its immediate environment. These processes are not unique to Saturn. Similar dynamics could influence the evolution of other circumplanetary disks, whether they are forming moons or, like Saturn's rings, gradually being absorbed by the parent planet. Understanding these destructive forces is just as crucial as understanding the constructive processes that lead to formation. Ultimately, Saturn's vanishing rings offer a humbling perspective on the impermanence of even the grandest cosmic spectacles. They remind us that the universe is a place of constant change, where even seemingly stable features are subject to transformation and decay. By studying the fate of Saturn's rings, we gain a deeper appreciation for the dynamic evolution of planetary systems, encouraging us to seek similar ephemeral wonders elsewhere, and to better understand the forces that shape the worlds beyond our own. The beauty we witness today is a testament to a fleeting, yet spectacular, chapter in cosmic history.